Hey friends, welcome to this video. In this video, we will learn how to create custom convolution block in TensorFlow using Keras API. For this video, we are going to build a simple convolution block which consists of a convolution layer, patch normalization layer, ReLU activation function, and a MaxPooling layer. So make sure that you watch the video till the end and also subscribe the channel. So let's start the code. First of all, we are going to import some libraries like TensorFlow and then some layers in the TensorFlow.keras layers import. So we're going to import all the layer. That's why I have written star. Star basically means import all the functions which are there in a class or anything. But I prefer you to write the name of the function, just like if we import from any other library like numpy, from numpy import star. So next time you have written star in both of them. So if any other person would see from which library the function is imported, he would not get it. But here we are using TensorFlow here, so it's simple. So for this tutorial, we are going to use Cifat and dataset. First of all, we are going to load the Cifat and dataset. Cifat tf.keras datasets. Now we're going to load the training and the testing dataset. X train. X basically mean images, and train it refers to the training data, and Y refers to the labels. Y train. So X train and Y train is the pair of images and the labels. And same we're going to have the X test and Y test as the test images and test labels. Cifat.load data. Now we're going to print the shape, the dimension, string, train, X train, load shape, print, F string, test, X test, load shape. Let's see the dimension images. Let's test. Also how many number of images are there. Okay, on it. Okay, so you can see 50,000 images are used for training and 10,000 images are used for testing, and the dimension of the images are 32 by 32 by 3. Okay, now we are going to normalize the image pixel and images pixel, the training and the testing, by dividing them with 255. Train is equals to train divided by 255, and same for the testing. So now the value of X train and the X test, the pixel value would be in the range of 0 and 1. So it would make it easy for us to converge, because now the loss would also be less small. So we have load our data set. Now we're going to build our custom convolution block, that is simple convolution block followed having convolution, patch normalization, ReLU, and MaxPooling. And we're going to name it conv block, and we are going to build it by extending the tf.keras.model class, and it consists of the two classes. First not class is the function, first is the constructor, that is init block, and here we can specify some parameter which we required while initializing the layer in this constructor function. First is the number of filter which we require for the convolution layer. Second is the kernel size. So kernel size is going to be 3 by 3 by default. Let's define it here only, so we know find it again and again. Now we're going to call the super function, because we are creating a child class and from the model class. So name of the child class self init. Now we're going to define some layers here. Here number of filters and the kernel size. That's enough. Second is batch normalization, bn. That's normalization. Third is ReLU, activation. The last is the pooling. We are going to use a 2 by 2 pooling. So we have created the layers, initialize the layer. Now into build the call function. This is going to receive the input x. Now here we going to perform all the operations on the input. Here x equals to first the x input passed through the convolution layer. Self.conv, and again x is equal to self.bn, batch normalization, and output of the previous input or the previous layer, that is convolution layer, and again it passes to the ReLU. Now we need to we use the pooling. So we create a parameter here called pool. If it is set to true, then we want to use the pooling operation. If pool is equals to true, then x is equals to self dot pool x. And if it is false, that is pool is false, then we don't want to use pooling. Return x. So this is our custom convolution block, a simple convolution block. So let's do one thing. Let's call this block like c1 is equals to conv block 32 number of filters, and input let's say x is tf dot zeros. Create full input 8 by 32 by 32 by. Now output for this block should be y c1, and if pool is set to true, then we're gonna print its shape. Let's print its shape. Okay, okay, okay. Some mistake is there. Okay, it should not be pool, it should be pooling. Simple mistake, everybody makes mistake. Let's also write one more line so that we won't get this lot of lines. Tensor these lines, necessary line. We can get rid of these lines. What OS? So after writing this line, we only get the error message. We won't get any extra unnecessary information. Okay, this. Okay, it should be like min, not in. It should be tff cpp min log level. Okay, now you can see no extra lines and just our. Now we have input is like 8 by 32 by 32 by 3, and output is like 8 by 15 by 15 by 32. Now let's set pool to false and see the difference in the output dimension. So 8 by 30 by 30 by 30, that's the difference pooling makes. Now next we are going to create model, simple function called build model, and inside that we're going to use our this conv block class, create the entire function. Input shape of the input, that is 32 by 32 by 3. First the inputs, we need to use the input layer and give it the input shape x. Now we're going to call our conv block number of filter first is 32, and give inputs as the input to this layer. Next is x, again the output this layer conv block. Okay, this time number of filter is double 64, and input is x, that is output of the previous conv block. Like this, I'm going to copy this block, and I'm going to change 64 to 128, and I'm also going to do one thing, set pool to false. Now next I'm going to call the global average pooling 2D, and input is going to be x. Next is the dense layer, and the output for the dense layer is 10. So the number of nodes for 10, as 10 is the number of classes for the far 10 dataset, and activation is equal to softmax. Now let's create the model, the TensorFlow model. Input would be inputs and next variable is output. So in this model class or function, first is first thing you should give it's the input, that is this input class, and next is the output layer, output. So I think these are all correct, and let's return the model. Okay, spelling mistake. RET model. So we have built the model. Now let's call it model equals to build model. Shape is 32 by 32 by 3. Model dot summary. Let's see if it work or still have any issue. Okay, so you can see we have built a simple function, or not function, a simple model where number of parameters are 95,430. Okay, now let's train it. So before that, let's go again the model. So you can see we've created the custom block. Now if this custom block is not there, then see how many lines you have to write again and again. So this is the benefit of creating a custom convolution block. So you need not to write these 4 lines again and again and again and again. You can just use the simple class and just get rid of those line. It also makes your code in less number of line, and also makes you more productive. So just imagine you have to write these lines 20 times. Okay, and just now you are not writing it, so it saves time and make you more productive. So that's the advantage of it, and also makes you easy to debug the code if you have any issue, because now you have to make changes in that original convolution block only. You have not go. Now we're going to train this classifier. First we need to compile it. Model.compile. Close for optimizer. Have done. Adam. Next is loss. Is sparse. Real quotient problem. Metric going to be accuracy. R. Good. Now we're going to train it. Model.fit is the X train, that is images. Y train the labels. Number of epoch 10. Batch size, let's say, okay, batch underscore size should be equal to, let's say, 128. Okay, so this is the training. Now we're going to evaluate the model after training. For evaluate, let's give it X test and Y test. Testing images and the testing label. Okay, let's run this. See if it works or still have any issue. Okay, see the summary for the model, and also starts training. Let's wait for these 10 epochs to complete. They won't take much time. So we can see the accuracy, the training accuracy is increasing. Let's start with 53% accuracy. Now let's see on what it end. Last. Okay, so we have a training accuracy of 81.2, and on the testing we can see 64.84 accuracy. So we have got 64% accuracy on the testing dataset. I know this is not that good, but the main objective of this video is not to get much accuracy here, is to see how we can build these custom blocks. Like you can also create ResNet block, DenseNet block. So in my next video, I will show you how you can use this block and create ResNet and dense block and use them for image classification. Okay. So I hope you just get the video, and if you like the content, then make sure you like the video, share it with your friend, and also subscribe to the channel. And if you still have any query, any problem, anything, then please comment below. I will try to answer all your query. Thank you. Have a nice day.